1.4. Test activities, testware and test roles. Testing is context-dependent, but at a high level there are common sets of test activities, without which testing is less likely to achieve test objectives. These sets of test activities form a test process. The test process can be tailored to a given situation based on various factors. Which test activities are included in this test process, how they are implemented, and when they occur is normally decided as part of the test planning for the specific situation. The following sections describe the general aspects of this test process in terms of test activities and tasks, the impact of context, testware, traceability between the test basis and testware, and testing roles. The ISO/IEC/IEE 29119-2 standard provides further information about test processes. Test planning consists of defining the test objectives and then selecting an approach that best achieves the objectives within the constraints imposed by the overall context. Test planning is further explained in Section 5.1. Test monitoring and test control involve ongoing checking of all test activities and the comparison of actual progress against the plan. Test control involves taking the actions necessary to meet the test objectives. Test monitoring and test control are further explained in Section 5.3. Test analysis includes analyzing the test basis to identify testable features. Associated test conditions are defined and prioritized, taking the related risks and risk levels into account. See Section 5.2. The test basis and the test object are also evaluated to identify defects they may contain and to assess their testability. Test analysis is often supported by the use of test techniques. See Chapter 4. Test analysis answers the question, what to test, in terms of measurable coverage criteria. Test design includes elaborating the test conditions into test cases and other testware, for example, test charters. This activity often involves the identification of coverage items, which serve as a guide to specify test case inputs. Test techniques, see Chapter 4, can be used to support this activity. Test design also includes defining the test data requirements, designing the test environment, and identifying the necessary infrastructure and tools. Test design answers the question, how to test. Test implementation includes creating or acquiring the testware necessary for test execution, for example, test data. Test cases can be organized into test procedures, which are often assembled into test suites. Manual and automated test scripts are created. Test procedures are prioritized and arranged within a test execution schedule for efficient test execution. See Section 5, 1.5. The test environment is built and verified to be set up correctly. Test execution includes running the tests in accordance with the test execution schedule. Test runs. Test execution may be manual or automated. Test execution can take many forms, including continuous testing or pair testing sessions. Actual test results are compared with the expected results. The test results are logged. Anomalies are analyzed to identify their likely causes. This analysis allows us to report the anomalies based on the failures observed. See Section 5.5. As completion usually occurs at project milestones, for example, release, end of iteration, test level completion. For any unresolved defects, change requests or product backlog items are created. Any testware that may be useful in the future is identified and archived or handed over to the appropriate teams. The test environment is shut down to an agreed state. The test activities are analyzed to identify lessons learned and improvements for future iterations, releases, or projects. See Section 2, 1.6. A test completion report is created and communicated to the stakeholders. Testing is not performed in isolation. Test activities are an integral part of the development processes carried out within an organization. Testing is also funded by stakeholders, and its final goal is to help fulfill the stakeholders' business needs. Therefore, the way the testing is carried out will depend on a number of contextual factors, including stakeholders, needs, expectations, requirements, willingness to cooperate, etc. Team members, skills, knowledge, level of experience, availability, training needs, etc. Business domain, criticality of the test object, identified risks, market needs, specific legal regulations, etc. Technical factors, type of software, product architecture, technology used, etc. Project constraints, scope, time, budget, resources, etc. Organizational factors, organizational structure, existing policies, practices used, etc. Software development lifecycle, engineering practices, development methods, etc., and tools, availability, usability, compliance, etc. These factors will have an impact on many test-related issues, including test strategy, test techniques used, degree of test automation, required level of coverage, level of detail of testware, test reporting, etc. 4.3. Testware is created as output work products from the test activities described in Section 1. 4.1. There is a significant variation in how different organizations produce, shape, name, organize, and manage their work products. Proper configuration management, see Section 5.4, ensures consistency and integrity of work products. The following list of work products is not exhaustive. Test planning work products include test plan, test schedule, risk register, entry criteria, and exit criteria. See Section 5.1. Risk register is a list of risks together with risk likelihood, risk impact, and information about risk mitigation. See Section 5.2. Test schedule, risk register, entry criteria, and exit criteria are often a part of the test plan. Test monitoring and test control work products include test progress reports, see Section 5, 3.2, documentation of control directives, see Section 5.3, and information about risks, see Section 5.2. Test analysis work products include prioritized test conditions, for example, acceptance criteria, see Section 4, 5.2, and defect reports regarding defects in the test basis, if not fixed directly. Test design work products include prioritized test cases, test charters, coverage items, test data requirements, and test environment requirements. Test implementation work products include test procedures, manual and automated test scripts, test suites, test data, test execution schedule, and test environment items. Examples of test environment items include stubs, drivers, simulators, and service virtualizations. Test execution work products include test logs and defect reports, see Section 5.5. Test completion work products include test completion report, see Section 5, 3.2, action items for improvement of subsequent projects or iterations, documented lessons learned, and change requests, for example, as product backlog items. 4.4. Traceability between the test basis and testware. To implement effective test monitoring and test control, it is important to establish and maintain traceability throughout the test process between the test basis elements, testware associated with these elements, for example, test conditions, risks, test cases, test results, and defects. Accurate traceability supports coverage evaluation, so it is very useful if measurable coverage criteria are defined in the test basis. The coverage criteria can function as key performance indicators to drive the activities that show to what extent the test objectives have been achieved. See Section 1, 1.1. For example, traceability of test cases to requirements can verify that the requirements are covered by test cases. Traceability of test results to risks can be used to evaluate the level of residual risk in a test object. In addition to evaluating coverage, good traceability makes it possible to determine the impact of changes, facilitates audits, and helps meet IT governance criteria. Good traceability also makes test progress reports and test completion reports more easily understandable by including the status of test basis elements. This can also assist in communicating the technical aspects of testing to stakeholders in an understandable manner. Traceability provides information to assess product quality, process capability, and project progress against business goals. 4.5. Roles in testing. In this syllabus, two principal roles in testing are covered: a test management role and a testing role. The activities and tasks assigned to these two roles depend on factors such as the project and product context, the skills of the people in the roles, and the organization. The test management role takes overall responsibility for the test process, test team, and leadership of the test activities. The test management role is mainly focused on the activities of test planning, test monitoring, test control, and test completion. The way in which the test management role is carried out varies depending on the context. For example, in agile software development, some of the test management tasks may be handled by the Agile team. Tasks that span multiple teams or the entire organization may be performed by test managers outside of the development team. The testing role takes overall responsibility for the engineering, technical aspect of testing. The testing role is mainly focused on the activities of test analysis, test design, test implementation, and test execution. Different people may take on these roles at different times. For example, the test management role can be performed by a team leader, by a test manager, by a development manager, etc. It is also possible for one person to take on the roles of testing and test management at the same time.